In this lecture, we're looking at the formation of ions, because once you see how they form ions, you'll know how to put compounds together. Important to know, the whole reason that atoms interact, well, not the whole reason, but a major reason that atoms interact is to obtain a lower potential energy state. All right? Within the atom itself, remember if we look at the Bohr model, and let's just look at the first three energy levels, make sure you understand. So n equals 1, n equals 2, n equals 3. Okay? Within an atom, low energy is that first energy, and then the second, and then the third. So if an atom is going to occupy an energy level, it will always go to the lowest one first. It's always going to be located in the first energy level before it goes to the second, before it goes to the third. Now, let's correlate that to, from the Bohr model and the quantum model, what's in the first energy level. In n equals 1, we only have s orbitals. In n equals 2, we have s and p. And n equals 3, we have s, p, and d. All right, so the electrons are going to go to that first energy level in the s orbital. Then they're going to go to the second in the s and then the p. In the third in the s, p, and d. Now, actually, it's a little confusing with this d, but we'll discuss that later. All right, so we'll just pretend this is what's going on. All right, so the idea is always you're thinking low potential energy. Now, when it comes to total number of electrons, there seems to be a special low potential energy when the s and p orbitals are filled. So in other words, when we have, in the case of helium, all right, helium has 2 electrons in that first energy level. Well, with 2 electrons, that energy level is filled. All right? All right. They're there by size if you want to pick one up.
I know.
Okay.
Thanks.
With the other noble gases, let's look at neon. Neon has 10 electrons. All right, and you see its valence electrons, those electrons that are in the outer energy level, are filled. And when we have these filled s and p orbitals, this is called a special lower potential energy. It is a characteristic of all noble gases. That's why they're very unreactive. They've got their filled s and p orbitals, and they're very happy about it. All right, this is what we refer to in chemistry. It's called the octet rule. Is that atoms will try to get to that. The main group atoms, those ones in the s and p block, will try to get to this octet. All right, or duet in the case of helium. So if you have like lithium or beryllium that are real close to, you know, all the others are going to try to get to this octet. All right. So with that in mind, once again, your periodic table that you have access to kind of looks like this, right? And this is referred to as the S block. And this is referred to as the P block. And this is the D block. And we're going to ignore this for now, all right? These are called transition metals, and these are called our main group elements. S and P are main group elements. All right, so our main group elements on the periodic table are neutral, but by forming ions, they can get to that noble gas status, that octet rule. So let's look then by all right, so generally speaking, we can take the group number and identify how close it is to that octet, all right? So in group 1 and group 2 and group 3, what they will do is they will usually lose those 1, 2, and 3 valence electrons. Because remember, in main group, the group number tells you how many valence electrons they have. So in group 1, 2, and 3, all right, for metals in group 3 has nonmetals and some metalloids in there. So really, we're talking about aluminum in group 3. They will lose 1, 2, or 3, so they will form cations. Those are positive ions, all right? And we'll ignore 4 because 4 is kind of, you know, it's halfway, it doesn't really know what it wants to do, gain 4, lose 4, so we'll just ignore that. But 5, 6, and 7 then, what they will do is they will add electrons. So in group 5, they'll add 3 and form negative 3. Group 6, they'll add 2 and form a negative 2. In group 7, they'll add 1 and form a negative 1. All right, so to show you how that works and to give you some basic practice with electron configuration, let's slowly work through those that are on the bottom of your page. For instance, here's sodium. Sodium on your periodic table has 11 protons. That means it has 11 electrons. So let me show you 1s, 2s, 2p, and 3s. All right, and the 2 electrons in each orbital will fill the 1s, and then they'll go to the 2s, and then they go to the 2p, and then that 1 valence electron. Group 1 has 1 valence electron. So when sodium forms an ion, right, and the purpose of forming the ion is to get to that filled outer shell there, okay, it will lose this valence electron. Okay, so that puts our ratio then of 11 protons to 10 electrons and gives us a, right there is our sodium plus 1. This is the reason that group 1 metals form a plus 1 charge. It's because they want to reveal that filled outer shell. Now the same thing is going to happen with magnesium and aluminum, all right? And now let's look at phosphorus. Phosphorus has got 15 protons, atomic number 15. So remember, we're going to go to the 1s, and then we're going to go to the second energy level. And in second energy level, we have S and P. And then we're going to go to the third energy level, and we're going to go S and P. All right? And then we're going to start filling these up. And notice in the P that I fill them singly before I double them up, and that's because it's lower potential energy to occupy an unfilled orbital than it is to share an unfilled, to share a half-filled orbital that has a particle in it with your same charge, all right? So it's all about low potential energy. Okay, so it's going to fill those singly, and then it's going to double up. And then it's going to go to the S, and now we're sitting at 2, 4, 6, 8, 10, 12. Remember, we have how many? 15. So this is how it goes. 13, 14, 15. All right? So this is neutral phosphorus. This is a phosphorus atom. Now, it wants to get these outer valence electrons. Remember, valence electrons are the ones in the outermost shell. How do you know? You look for the largest number. These then would all be the inner core electrons. All the other electrons that are not the valence electrons. And these valence electrons, if they can get to noble gas configuration, in other words, filled S, then they are at a lower potential energy. So what phosphorus will do, and we'll get into the why and how later, all right, is it will add 3 electrons. And I wrote those in a different color so you could see it. So by adding 3 electrons, that gives it a filled outer shell. And that's why every atom, you know, you go phosphorus, nitrogen, same idea, astatin, or is that arsenic? I always confuse it, sorry. All right, so what we're going to get then is that P3 negative. All right, so my metals, my group 1, 2, and 3 metals are going to shed an electron and form a cation, a positive ion, so that they have the filled outer shell underneath. My nonmetals, group 5, 6, and 7, this is main group, this is not transition metals. To obtain noble gas configuration, they're going to gain the respective amounts. Let's look at a sulfur, all right, we'll go to sulfur, and it's got 16. So 1s, 2s, 3s, 3, boy, I'm just, 2p, 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 3s, 3p. All right, we've got 16 electrons. It starts in the lowest energy level, the lowest orbital type. So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so as you can see, we have 6 valence electrons because this is group 6. It's going to correlate to how many valence electrons. On your periodic table out on the right, those numbers, those are going to tell you which energy level those valence electrons are in. So your periodic table just gives you a wealth of information. All right, well, we only have to have 2 electrons to get a filled outer shell. So all nonmetals in group 6 are going to gain 2 electrons to get a filled S&P valence electrons, and then that is why all nonmetals in group 6 are going to form a -2. Okay, so that is the formation of ions, why they form it. Now we're going to take that information and start putting compounds together and how to name them.